Today we solve some problems. So the first problem, suppose the differential equation, consider the differential equation x square 2 times cos of y square into dx plus minus xy sin of y square into dy equal to 0. Then which of the following is true? First option, e power x is an integrating factor. Second option is e power minus x is an integrating factor. And third option is 3x is an integrating factor. The last option is x cube is an integrating factor. So which of the following is an integrating factor of this differential equation? So how to find this one? So anyway, this is not a exact equation, that's why we find the integrating factor. So what is m? M is 2 cos y square. And what is n? Minus xy sin of y square. Now what is dou m by dou y? Is 2 minus sin y square into 2y. And what is dou n by dou x minus y sin y square, because y is constant here. So therefore these two are not equal, because we have here minus 4y, but here we have y. So anyways, these two are not equal. Therefore this is minus 4 times y sin y square, but this is minus y times sin x. So therefore these two are not equal, therefore it's not exact. So we got to find either 1 by n thing. So better we find 1 by n dou n by dou x minus dou m by dou y. If it is function of x alone, then we can easily find the integrating factor. So this is equal to 1 by what is n minus xy sin y square. What is dou n by dou x is minus y sin y square minus already minus there, therefore plus 4 times y sin y square. So therefore this minus 1 times, this is 4 times, so therefore 3 times y sin y square. Therefore we can cancel all the things, therefore we get numerator we have 3, the denominator we have minus x, because y into sin y square is cancelled. So this is a function of x alone, therefore the integrating factor is e power minus 3 by x dx. So this is equal to e power minus 3, integration of 1 by x is log x. Okay, I am correct. So therefore you will get 1 by x cube. Oh, I think I did some mistake. Where I did mistake? Should be plus, right?
1 by m, sir.
1 by
M.
No, 1 by n into.
M into.
Sorry?
So it's 1 by m into dou n by x minus dou m by y.
No, otherwise it will not cancel. Okay, if it is suppose okay, good. So suppose I take the first one is dou n by dou n, I take m. Okay, but I want to take n, because n only contains y sin square. Therefore it should be dou m by dou y minus dou n by dou x. Okay, if it is take m, this is the true, right? So in this case, so that's it, because n contains y sin y square, that's why I take 1 by n. So therefore dou m by dou x dou y minus dou n by dou x. Now I think you will get this is actually 4 times, okay, minus 4 times minus 4y this, and then this just minus 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 plus, so we get minus 3, so therefore we get 3 by x. Now we get 3 by x is the integrating factor, therefore this should be plus, this also plus, therefore we get x cube. So s cube is that integrating factor. Got it? Okay. Next problem. Okay, similar type of problems we can see. Okay, so the next problem. Second problem is given that suppose there are two solutions is given, y1 and y2 are two linearly independent solutions. Okay, linearly independent solutions of the differential equation y double dash plus p of x y dash plus q of x y equal to 0. Okay, where p and q are continuous functions of x. Suppose if we define y3 is the combination of y1 y2, suppose we take a times y1 plus b times y2, and y4 is defined some other constant c times y1 plus d times y2. Okay, suppose this y3 and y4 are linearly independent, y3 and y4 are linearly independent solution, then what is the relation between this a, b, c, d? So first option is AD should be equal to BC, and the second is AC equal to BD. Third option is AD not equal to BC. Then last option is AC not equal to BD. Now these are two equation, and then we know that y1 y2. Therefore if you write the matrix form of this equation, we have A B C D times y1 y2 equal to y3 y4. Okay, so actually we know that if the determinant is non-zero, then it is linearly independent, because the Wronskian is non-zero, it is linearly independent. Okay, so therefore you will get what is the determinant of this matrix. We have to check if the matrix is non-zero, then is linearly independent. Okay, so therefore what is the AD minus BC should be not equal to 0. This is the determinant. So if you take this side, we get AD should be not equal to BC. So if y1 y2 y3 y4 is linearly independent only when this AD should be not equal to BC. Therefore C is the correct answer. Okay, because the determinant is non-zero, that is the Wronskian is non-zero, is linearly independent, right? So that is the Wronskian, even if you take this y1 y2 outside. Yeah. So another problem, suppose give a system of two equation. So yesterday we solved some different method, but today we solve some other method. Okay, so the third problem, suppose we have a two solution, y1 of x and y2 of x are differential functions, solutions of the simultaneous equation. So the y1 is a solution for this equation dy1 by dt or dx minus y1 minus y2 equal to e power x. So y1 is a solution of this one, and y2 is a solution of this equation, 2 times dy1 by dx plus dy2 by dx minus 6y1 equal to 0. Then what is y1? Then what is y1 of x? That is a question. If y1, y2 are this, then what is the y1 of x? Okay, better to write the options, maybe we can directly solve it. Okay, we have to form a single equation. So we need a y1, therefore you have to consider the first equation and then differentiate with respect to x. Okay, so maybe we call this equation number 1, then equation number 2, differentiate 1 with respect to x, therefore we get a d square y1 by dx square minus derivative of y1 is dy1 by dx minus dy2 by dx, and then what is the derivative of e power x? E power x. Now we can replace this term by this term, so you can keep this one side and then take everything to that side and then replace dy by dy2 by dx. So therefore what will get? So you'll get d square y1 by dx square minus dy1 by dx minus d2 by this one is nothing but 6 times y1 minus 2 times dy1 by dx equal to e power x. Okay, if you multiply minus and then we have a plus 2 and then already we are minus 1 times here, therefore we have a plus times, therefore we have a d square y1 by dx square plus dy1 by dx minus 6y1 equal to e power x. Now this is a second order differential equation in terms of y1 and dx. Therefore you know how to find this y1. So therefore what is the complementary, so therefore auxiliary equation. So auxiliary equation is m square plus m minus 6 equal to 0. So therefore 3 and 2 are the roots, therefore m minus 2 into m plus 6 3, I think so. Okay, so therefore the roots are 2 and minus 3, therefore minus 3 comma 2 are the roots, therefore the complementary function is c1 times e power minus 3x plus c2 times e power 2x. Now what is the particular integral? So the right hand side function is e power x, therefore 1 by d square plus d minus 6 into e power x. So just substitute x d equal to 1. Okay, so that is a thing, right? So substitute d equal to 1, we get 2 minus 4 is minus 4 into e power x. So just add these two, you will get solution. Therefore y1 of x equal to c1 times e power minus 3x plus c2 times e power 2x minus 1 by 4 e power x. So this is a solution. Maybe it is some option, one of the option in this question. Okay. Now another problem. Simple. Okay, the next one is maybe we have to do some work. I think fourth problem, or yeah, fourth problem. So what the problem says, suppose k is constant. If k is constant and is given that xy plus k is e power x minus 1 whole square by 2, and this satisfies the equation x into dy by dx equal to x square minus x minus 1 times y plus x minus 1. Suppose this function satisfies this equation, then what is k? Then k equal to what? So the first option is 1, the second option is 0, third option is -1, fourth option is -2. So it is given that this is a root. So what we have to do? So just to differentiate the given equation xy plus this one into this, and then finally we will get, because this is a solution, right? Therefore the given equation is xy plus k times this one. So it is given xy plus k equal to e power minus x minus 1, okay, minus or yeah plus only, so square by 2. If we differentiate this with respect to x, okay, if you fix x and then differentiate y, you will get a thing. Therefore if you fix y differentiate x, we will get 1, plus if you fix x differentiate y, we get dy by dx, and then the derivative of k is 0 because k is constant, and this equal to derivative of this is e power the same thing is nothing but e power the same thing, but if we differentiate the power, 2 times x minus 1, 2 cancel, we have a x minus 1. This is a derivative. Now we have a x into dy by dx should be minus y plus x minus 1 into e power x minus 1 square by 2, but it's given that the right hand side is this thing, okay. So otherwise maybe you can replace it. So this is equal to, it is we know that given k, from this we can write what is k. So therefore k equal to minus xy plus thing, right? Therefore what is, so replace okay, directly we can replace this e power minus x square by 2 is xy plus k. Therefore minus y plus x minus 1 into this value is nothing but xy plus k. So just to multiply, so minus y x into x, x square y, x into k, this is kx, and then minus 1 into xy minus xy minus k. So already is given that in the problem, so the right hand side is this value, so x square minus x, so therefore this should be equal to x square minus x minus 1 into y plus x minus 1. So we can rewrite this side is, we can take y outside, so in this term we have x square, and then from here if you take y you have x, and if from here you can take y outside, we have minus 1. So the remaining terms you can take k outside, we have x minus 1. Therefore compare this one, so here the coefficient of x minus 1 is 1, here k, therefore k value should be 1. K value should be 1. Okay. So the next thing is, I think the second order derivatives, we have to look at that. Okay. Fifth problem, suppose given that f is a function from r to r2 to r2, okay, sorry, r2 to r, defined by f of x comma y equal to x square y by x power 4 plus y square if both x y at least one of the coordinates non-zero, that is non-zero, then this is a value. Suppose both are 0, that is the order pair x comma y is 0, then is defined the value should be 0. Okay. So now what is the question? Which of the following statements holds regarding the continuity and then existence of partial derivatives at the point 0, 0? So the first option, both the partial derivatives of x exist at 0 comma 0 and f is continuous. F is continuous at the point 0 comma 0. And then second option is same thing, but f is not continuous. Both the partial derivatives, maybe I can write fx and fy exist at the point 0 comma 0 and f is not continuous, and f is not continuous at the point 0 comma 0. The third option is one of the partial derivatives does not exist, maybe anything but one of the partial derivatives. One of the one partial derivatives does not exist. One partial derivatives the derivatives of f does not exist at the point 0 comma 0 and f is continuous. F is continuous at the point 0 comma 0. Now the last option, again one of the partial derivatives does not exist, again f is not continuous. One partial derivatives does not exist, one partial derivative of f does not exist at the point 0 comma 0 and f is not continuous at 0. F is not continuous at 0 comma 0. So first you got to check the function is continuous at the point 0 comma 0 or not. So you can take some path. So anyway you can take y equal to some via y equal to some x square something, okay. So mx square via parabola, okay. So along the line, so what we have to check? We have to check the limit x comma y goes to 0 comma 0 f of x comma y. It should be 0, okay, if it is f of 0 comma 0. But what is this limit x comma y goes to 0 comma 0, f of x comma y is nothing but x square y by x power 4 plus y square. Now if you take the line along y equal to mx square, this is a parabola, so anyway passing through origin, right. So if you take any path, in particular if you take this path, so therefore if you take along x comma y goes to 0 along the path y equal to m square, y equal to mx square. Therefore if substitute here, therefore limit x comma y goes to 0 comma 0, if substitute y equal to here, we have a m x power 4 in the numerator. Denominator also we have x power 4 plus y square is m square x power 4. So we can cancel x power 4, we get m by 1 plus m square. So therefore the limit is not unique. If you take the different path, there is different parabola y equal to x square, y equal to 2x square, y equal to 3x square, we get the different limit, but the limit should be always same if it is continuous. So therefore the limit does not exist, therefore f is not continuous at 0 0. So therefore the limit is not unique, therefore f is not continuous at the point 0 comma 0 because the limit is not unique. Now we have to check the partial derivatives. So what is the partial derivatives? You have to differentiate f at the point, okay. So dou f by dou x you have to find at the point 0 comma 0 it exists or not, and then you have to find dou f by dou y at the point 0 comma 0 exist or not. Okay, so if you find this, what you'll get? So actually this is nothing but limit x goes to 0, because y is treated as a constant. Actually this is actually fx at the point 0 comma 0. So this is nothing but actually limit h goes to 0 f of 0 plus h comma 0 minus f of 0 comma 0 by h. These are first partial derivatives at the point 0 0. So this is nothing but limit h goes to 0, this is f of h comma 0 minus f of 0 0 is 0, because at the point 0 0 the function is 0 by h. What about this? Again this is 0, because if at least one coordinate is non-zero, the function is x square y by x power 4 plus y square. Now the second coordinate y is 0, x is h. Anyway, the product, the numerator is always x square into 0. That is h square into 0, anyway 0. Therefore, it's totally 0. So therefore, the first partial derivative exists at the point. Now we got to similarly check for this. So this is nothing but limit h goes to 0, f of 0 comma 0 plus h. Now the second variable is varying, f of 0 comma 0 by h. So again this is nothing but limit h goes to 0, f of 0 comma h minus f of 0 is 0 by h. So anyway f of 0 comma h also 0, because one of the coordinates 0, therefore the product 0, therefore we get 0. So for the both partial derivatives exist at the point 0 0, but f is not continuous at 0. So therefore the correct option is the second one. Both the partial derivatives fx and fy exist, but f is not continuous at the point 0 0. Okay, now the next one. So similar, you have to find, actually the maximum question asks from the find the integrating factor of the equation or same thing. So I think 6th or something. Suppose we have a equation, okay, y square minus 3xy times dx plus x square minus xy into dy equal to 0. So one of the integrating factor of the differential equation is first option 1 by x square y square. Second option is 1 by x square y. Third option is 1 by x y square. The last option is 1 by xy. So what is the integrating factor of this one? So similarly you find the dou m by dou n, all the things. So therefore m equal to y square minus 3xy and n is x square minus xy. Actually this is another form, right? So if you take okay, anyway the given equation, if you take y outside, we have y minus 3x, right, into dx plus if you take x outside from this the equation, we have x minus y into dy equal to 0. So as I mentioned already, so there is another format. Suppose we have a function of, okay, product, okay, anyway this function should be a product of xy. Okay, so anyway it's a function of xy. So anyway we can directly solve this problem. It's not issue. We try, otherwise we can go to this rule. So dou m by dou y is 2y minus 3x and dou n by dou x is 2x minus y. Anyway both are not equal. Now you just to find,
Sir, we can use another rule now, sir.
which one is homogeneous, right?
Yes, sir.
Yeah, we can use the homogeneous also.
1 by mx plus ny will be the
Okay, 1 by mx minus or plus.
for homogeneous it is plus, and for another rule it is given as 1.
Okay, so we will try this one. So this is 1 by x into this, x into m, therefore xy square minus 3x square y plus, if you multiply y, we have x square y minus xy square. Okay, so therefore this xy square cancel, and this is 3 times and this is a 1 times, therefore we have a minus 1 by 2 x square y, but minus is there, right? I think mx minus ny, but in this option we don't have this number. If suppose if we take minus, it will work.
But it is in the function of f of xy into y dx plus f2 of xy into x dy is equal to 0.
Yeah.
That form we can get this answer.
So in that case, what is the integrating factor?
In that case, integrating factor will be 1 by mx minus ny.
Okay. So this is a sort of form, right? Therefore, but you will not get. Okay, if you take minus, if you find 1 by mx minus ny, you'll get the same thing, but xy square minus 3x square y minus x square y plus xy square. So you will not get anything. You will not it not cancel anything, right? So then now we'll get it. So better we can use this method. Otherwise, if you just check, otherwise you can go for our original method. So we try to find this one, and I think both are homogeneous. I think so. It's both are homogeneous. So if mx plus ny is non-zero, then 1 by mx plus ny is integrating factor. But it's function of xy, but not, this is not a function of xy. If you take y outside, that should be in terms of xy, x into y, x comma y, but not xy. Should be xy. Okay. Otherwise, we will not use this one. So we can use this only when that f1 of xy, this function of xy. Maybe we can use this because both m and n are homogeneous of degree 2. Therefore, we can work this, but we miss some constant here. Maybe they will miss some constant. Okay. So therefore, answer should be x square y. This is the only possible case. Maybe there is some mistake in this problem or somewhere. Okay. So the next problem. So otherwise, maybe I did some mistake. You can clearly check. So once again, we will look at it. What is mx plus ny? So I think m and n are correct. So we have to multiply x to this m. So therefore, x y square minus 3x square y plus, if you multiply with y to n x square y minus x y square, right? Yeah. So we are correct, but maybe so they don't bother about this the factor. Okay, so you can cancel this. We have a minus 2x square y. Therefore, x square y, 1 by x square y is the integrating factor. If suppose you look at the answer, so it is given in the option is minus 1 by 2 x square, you have to pick that one. Otherwise, just to remove the constant and then you can find this one. Okay, so the next problem. Okay, so the next one is 6th or 7th. Suppose C1 plus C2 log x whole divided by x is a general solution, is the general solution of the differential equation. What is the differential equation? X square dy by d square y by dx square plus kx dy by dx plus y equal to 0, where x is positive. Then what is the value of k? Then k is what? This is a Euler-Cauchy equation, right? So options are, first option is k is 3, second option is minus 3, third option is 2, and then fourth option is minus 1. Now this is a Euler-Cauchy equation. Therefore, what is the, you have to substitute x equal to e power t. So you have to reduce this equation into d minus 1 times y plus k is a constant, k times d plus y, that is 1. Okay, if you take y, then y equal to 0. So therefore you will get a d square minus d plus kd plus 1 times y equal to 0. So if you take d outside, we have to k minus 1. So d square plus k minus 1 into d plus 1 equal to at y equal to 0. So this is the equation. So you have to write the auxiliary equation and then find the solution. So and then it's given that the C1 plus C2 times log x whole divided by x is also is given the general solution. Okay. So therefore, what is the solution? So just to find the auxiliary equation is m square plus k minus 1 times m plus 1 equal to 0. Therefore, what is that value of this one? So otherwise we can say the discriminant of this one 0. So what is the solution? What is the values of k? Sorry, what is the solutions for this one? And we know that is given that okay, maybe we can rewrite the solution is given by C1 plus C2 times log x whole divided by x. So this is nothing but C1 by x plus C2 times log x by x. So this is in terms of x. So if you change this in terms of t, what you will get? Actually, you take the substitution x equal to e power t. Therefore, log x equal to t. So you will get. I think if you solve this, the solution become maybe minus 1 and 3. So if you take, okay, if you take, because the discriminant b square minus 4ac, okay, should be, okay, the discriminant. So if you write the formula minus b plus or minus square root of b square, that is k minus 1 whole square minus 4ac, that is this one. So that should be 0. Okay, so the discriminant should be 0. So therefore what you will get, that is k minus 1 whole square minus 4 should be 0, because the what is the formula for this quadratic formula? Minus b plus or minus square root of b square minus 4ac by 2a. So the solution, if the discriminant, this is the solution, therefore the discriminant should be 0 here. Okay, so k minus 1 whole square minus 4 equal to 0, therefore k minus 1 square is 4, therefore k minus 1 is plus or minus 2, therefore what is k? Minus 1 and then 3. So therefore if substitute k equal to minus 1 in this equation, you will not get the solution, this one. Therefore k equal to minus 1 is not possible, the only possible value is k is 3. Therefore in the option k equal to 3, because if substitute k equal to minus 1 and then find the equation, this equation reduces to, if substitute k equal to minus 1, you will get m square minus 2m plus 1 equal to 0, and this is nothing but m minus 1 whole square. Therefore the roots are repeated, that is 1. Therefore the solution is c1 plus c2 times x times e power t, but e power t is nothing but log x, because after you replace, okay, this is t times, okay, so therefore t is nothing but log x, and this should be x, we will get x into log x, but the solution is whole divided by x. Therefore if k equal to minus 1 will not be a solution, but if take k equal to 2, maybe you will get a solution, that is equal to 2 plus 1, that is minus is the solution. Okay, if subject k equal to 3, the equation becomes m square plus 2m plus 1 equal to 0. So therefore the roots are minus 1 minus 1. Therefore the solution is c1 plus repeated c1 plus c2 times t into e power minus t. But if you substitute in terms of x, so c1 plus c2, t is nothing but log x, so e power t is nothing but 1 by x, because e power minus log x is nothing but 1 by x. Now we get the solution. Therefore if we take k equal to 2 k equal to 3, we will get a solution. So that is the answer. Okay, now the next problem. Almost we solve this problem. So maximum they will ask integrating factor, find the integrating factor. Okay, so next problem. Eighth or something. So what is the integrating factor of x dy by dx minus 5x, sorry, not minus 5x, x into this plus 3x plus 1 into y equal to x into e power minus 2x. So what is integrating factor of this equation? So the options are, first option x into e power 3x, second option is 3x e power x, third option x into e power x, fourth option x cube e power x. So how to change, how to find this? First you got to write in the first order differential equation. So you divide x both the side and then get the first order differential equation and then find pq, then e power integral p dx is the integrating factor, right? So if you divide x both the side, we get the standard form of first order differential equation, dy by dx plus 3x plus 1 by x times y, and here x cancel, we have e power minus 2x. Now what is p here? 3x plus 1 by x, and q is e power minus 2x. This is standard form of first order differential equation. Now the integrating factor is e power integral p dx is the integrating factor. So therefore e power integral, if we cancel x, we have 3 plus 1 by x into dx. So therefore this is e power, if you integrate separately, integral 3 is 3x and integral 1 by x is log x. if you suppose you split, you get e power 3x into e power log x, but e and log are cancelled, we have x into e power 3x. So this is the x into e power 3x is the integrating factor. Okay, so the next problem, ninth problem. Suppose what is the general solution of this equation x square. So this Euler-Cauchy equation is very important. Okay, the x square. So what is the general form of the Euler-Cauchy equation? X square y double dash plus ax y dash plus by equal to some function of x. Okay, so you have to substitute x equal to e power t, and then finally we have to substitute t equal to log x, so you will get the solution. So if substitute that, you will reduce the constant coefficient differential equation. So d square y by dx square minus 5x dy by dx plus 9y equal to 0. What is the general solution? So the first option are c1 plus c2 times x into e power 3x. So the second option is c1 plus c2 times log x times x cube. The third option is c1 plus c2 times x into x cube. So the last option is c1 plus c2 log x into e power x cube. Okay, now after substitution, this reduces to the x square into d square y by dx square reduces to d into d minus 1 into y minus 5 into x into dy by dx just to replace by d plus into y and 9y equal to 0. So if you take y outside, therefore we get d square minus d, already we have 5d, therefore we have 6d plus 9 times y equal to 0. So therefore the auxiliary equation is m square minus 6m plus 9. So this is nothing but m minus 3 whole square. Therefore the roots are 3 and 3, same and real. Therefore the solution y, because there is no particular integral here, because the right hand side is 0. Therefore the y of x is c1 plus c2 times t, because we everything we have in terms of t, into e power 3t. But after changing these in terms of x, so this is y of t. Now what is y of x? c1 plus c2, what is t? Log x. And here substitute x equal t equal to log x, log e cancel, we have x cube. Okay, so therefore the second is the correct answer. Okay, so next problem. I think almost we solved this some problems. Okay. Other sort some test question. Okay, maybe we'll ask one more question. Tenth question. Suppose we have a differential equation sin x dy by dx plus 3y equal to cos x. Okay, so find the integrating factor. What is the integrating factor? So the first option is e power tan 3x whole divided by 2. So the second option is log of tan x by 2. So third option is tan cube x by 2. Then fourth option is tan x by 2. What is the integrating factor? So how to find this one? So just you have to write in the standard form of first order differential equation. Therefore you have to divide sin x both side. So therefore we will get dy by dx plus 3 by sin x into y equal to cos x by sin x, that is cot x. Now what is p? 3 by sin x. What is q? Cot x. Now what is the formula for integrating factor? E power integral p dx. E power integral p dx. So 1 by sine is nothing but cosecant. Therefore e power integral cosecant x dx. But what is the integration of cosecant x thing? Equal to e power integration of cosecant is I missed the 3. Okay, so 3 times log of cosecant x plus cot x. Log of cosecant x plus cot x is the integration of thing. We have to put minus also. Minus log of. Okay. So if you cancel this log and e, we have 1 by this cos x plus cot x whole cube. Okay. So therefore 1 by cosecant x plus cot x whole cube. So cosecant x is 1 by sine, cot also sine by cos. We have the denominator is cos, sine, you can take the numerator, therefore we have sine cube x. The numerator we have a 1 plus cos cube. Okay. So now 1 plus cos x is nothing but, maybe you can use the formula. We know that, okay, maybe we can replace here. It's nothing but sin x whole cube. So 1 plus cos is nothing but cos x by 2, 2 cos x by 2. Okay, so we know that there is a formula. What is that? Cos square x is 1 plus, I think, cos 2x by 2, right? So therefore what is this? But here instead of x we have a instead of we have 2x, we have x, therefore replace x by 2, therefore cross multiply 2, we have in the denominator 2 times cos square x by 2 whole cube. And then we know the formula for sin 2x. So sin 2x is 2 sin a cos a, 2 sin x cos x. Okay, but here instead of 2x we have x, therefore we can multiply 2 and then divide by 2, therefore 2 times x by 2, therefore we can write 2 sin x by 2 cos x by 2 whole cube. But anyway we can write 2 cos square x by 2 whole cube. We can cancel 2 and then 1 cos, therefore we get sin by cos tan x by 2, tan x by 2 cube, that is tan cube x by 2. Okay, so that is the answer. Tan cube x by 2 is the integrating factor. So you have to reduce the first order differential equation and then find p, then just integrate, you will get raise the power e and then integrate. So that is the thing. Okay, now maybe solve almost some problems. So just to try this integral value, maybe I will write the problem instead, just to try it, or 11th problem something. Find the volume of the portion, the volume of the portion or region or portion of the solid cylinder, of the solid cylinder cylinder x square plus y square is less than or equal to 2, bounded above by the surface. What is the surface? Z equal to x square plus y square, and bounded below by xy plane, and bounded below by the xy plane. Is what? What is the volume? So the first option is pi, the second option is 2 pi, the third option is 3 pi, the fourth option is 4 pi. So first you have to write what is the surface, what is the function, and then you have to find the volume. So how to solve this one? So you have to find, actually this is a function in 3 variable, right? No, anyway it's a function in from R2 to R anyway. So you have to find double integral of the region volume into what is the function here by the surface. Therefore f of x comma y is x square plus y square. Okay, now you have to find the value of f of dx, f comma y, dy dx something, where maybe. So what is the value of this? Okay, now it's a cylinder in the xy plane. The base is xy plane. Now what is the range for x and range for y? So anyway both are positive, right? Because given that x square plus y square is less than or equal to 2, therefore this is less than or equal to x square as well as y square. Therefore y is less than or equal to root 2, x also less than or equal to root 2, and both are positive. And then you just try, you will get what is the answer or not. So the answer is 2 pi. You have to try y. Okay, so maybe I can stop now.